So in this lecture we are going to discuss about our second phase, so that is design, and this is the second phase of our software development life cycle. So in the first phase it was requirement engineering. So at the end of our requirement engineering phase we have requirement specification in our hand. So what does that requirement specification contain? So it contains all the functional and non-functional requirements, right? So once the functional and non-functional requirements are agreed upon, then we start designing. So designing is actually deriving a solution which satisfies software requirement. The specification of requirement engineering defines what the system will do, and the design process defines how we are going to do that. So that means in the design phase we are actually answering how to solve the problem. So finding the right boundary between these two is a key issue. So from here we understand that software engineering is actually the process of building a program while satisfying the problem's functional need and not violating its non-functional requirement. So we will design or build our program in a way which will satisfy both the functional requirements and it will also not violate the non-functional requirements. So during this time, during design, the system is actually decomposed into parts that each have a lower complexity than the system as a whole, and while the parts together solve the user problem. So in this part we will actually decompose our problem into smaller parts and we will solve those smaller problems, and then we will combine it, and as a whole it will solve the user problem. So in this part we are actually creating models of our problem, and then we will represent those models using graphical presentations. So entity relationship, data flow diagram, object oriented notation, those are actually graphical representation models. We will learn about this object oriented notation in chapter 5. So when we will start our chapter 5 we will have better understanding of these graphical representations. But for now you can simply think flowchart as a graphical representation. So flowchart, if you depict a system using flowchart, it will not give you all the details, but it will give you some idea or some ideas. It will give you a model of how you can implement the system. So there are actually 4 stages of design. So the first is understanding the problem. So you have to understand the problem from different angles. You have to think it from different perspective, and then you will find the solution from different perspective. So the second phase is from those different perspective you will choose the most appropriate one using your according to your available resources or designer's experience. And then in the third phase you will describe your solutions, and you will not give all the details, so you will just give them an abstract idea, and you can do this using graphical graphical representation, and you will repeat this process until you get your final design. So we can split the design phase into 2 sub phases. The first one is high level design and the next one is detailed design. So high level design is also called as architectural design. So architectural design is actually it's not showing you all the details, it's just overall module structure and the relationship among modules. So that means you will divide your whole model into different components, different smaller parts, and then you will show the relationship between those smaller parts. So that's our architectural design. It's not giving you any details, but in detailed design you have to give detailed description to each of those smaller components. So architectural design, we can say that architectural design is the process of carving up the program into components and assign responsibilities to each component and talking about how the components are going to interact with each other. So that means you will divide your model into different components, smaller components. You will identify what's the task of these smaller components, and then you will just show the relation between the smaller components. So that's your architectural design. And in detailed design is the process of dealing with the individual component. So here we are going to deal with individual components or individual modules. So here particularly with respect to data structure and their algorithms. And the design notations here could be pseudocode, structured programming, flowcharts, etc. So here you have to define the data structure, the algorithms for each module. But you don't have to actually write that module, that algorithm, right? So you will simply give them the pseudocode of your algorithm, and in the implementation phase we will implement the algorithm. So in the design phase, in the detailed design, we're giving them our data structure, we will give them our algorithm, but we will not give them the code. Code will be done in implementation phase. Here you will simply give them the pseudocode, or you can give them the flowchart, like how your steps of the algorithm will flow. So this is actually the basic sequential design of how design is performed in software engineering. So this is giving you more steps, more detailed design. So here the input is requirement specification, right? So from there we will start our design activities. So you can see that there are multiple number of design activities, and the outcome of each activity is shown below, which is nothing but specifications. So the first one, we have requirement specification. That means we have all functional and non-functional details. So from there we will start our architectural design. So architectural design actually broadly identifies the subsystems. So once we identify all the subsystems, we get system structure, system architecture. So from system architecture we start abstract specification. So here we will specify subsystems and we define what each subsystem will do. So from there we get software specification. So from software specification we will start our interface design. So in interface design we identify what are the various interfaces which is actually being connected between two different subsystems, and how are they interrelated with each other. And the outcome of the interface design is interface specification. So from here we will land on component design. So component design actually defines what services each subsystem is going to perform, and the output of this is component specification. So from here we will start data structure design. So data structure design, actually here we define the arrays, the table structure, we define database management system, those things, and then from here we will get our data structure specification, and then we will finally land up in algorithm design. So here we design algorithms for problem functions. We will actually define the pseudocodes here, and then later we convert the algorithm into a working program. So what will be the produced documents in this design phase? So it will be a design documentation. So if we talk about software development for a large system, then the system are likely to be complex, right? And then we need a good design documentation. So different applications require different kind of documentation, but traditionally design documentation has included information about the components you have carved the system up into, and what are the responsibilities of those components and what are their data flows and so on. So, and also we have to provide a user manual at the end of this design phase.